All right, excellent. So hi, I think some folks joined late, maybe after the introductions. Shawn Madden here. I'm a solutions engineer based out of the Bay Area. I'm going to talk to you a little bit about our Grafana Loki solution for logging. And let me just quickly get all the buzzwords out of the way right up front. Tell you what Loki is. Horizontally scalable, highly available, multi-tenant log aggregation system. It was inspired by Prometheus, and the goal of it is to be very cost-effective to operate. It doesn't index the full context of the logs, which I'll talk to you a little bit about in a minute, but rather labels for each log stream. A lot of similarities. If you're familiar with Prometheus, you'll see a lot of similarities here between what we're doing with Loki and how it interacts with Prometheus. And what this all means is when the creators first came up with Loki, they wanted to create a logging solution that is cost-effective, fast, simple, and compatible with other tools that are out there in the current observability space. And this tweet really encompasses why Loki was built. So, developers in the past and even the present, use grep and sort and have tried in the past to find ways to, go through log lines and understand what's going on. I've done it. I'm sure all of you have done it as well. And this may work very well for, either a small subset of log lines, but when you start doing aggregations and trying to debug at scale, just give me grep really doesn't work. And the overall developer experience isn't very good. And when you need to solve problems quickly, it's not helpful. And that's not just for the developers, but for the operators as well. So if you're an operator, you can imagine working in this kind of a system where you have many different tools. Most of the customers I speak with have, 5, 10, 20 tools even across metrics, logs, traces, APM, and you're context switching among many different platforms. And so you're going from window to window, trying to figure out where things are. And also many of these different platforms are owned by different groups. So trying to, grab metrics and traces and correlate them together becomes extremely complicated and is very complex. So overall, the three main challenges that we hear with current logging systems are, number one is that they're hard to scale. Traditional systems are not designed for high volume log analysis. So it makes operations very hard to scale. It's also expensive. It's expensive because people and hardware are both expensive, and there's a lot of licensing involved. And the third one is being able to correlate your data is also very challenging. Excuse me, you can hear my dog in the background whining over here looking at me. It's very hard to correlate. So when you want to look at your metrics and your logs and correlate them together, it's very, very difficult to do. So with Loki, what we've done is set out to make things easy to operate and maintain at large scale, lower the TCL because, as I'll talk about, the minimal indexing that's required, and then seamless integration with a lot of the current platforms that are out there in the ecosystem today. So the three main things that I see when it comes to Loki is looking at it, you see that we have a powerful query language. LogQL is a query language, very similar to PromQL in syntax. It has the same similar things like filters and parsers, and you can turn the logs into very, very rich visualizations and do things like rate and count and sum and some really cool log aggregations. Number two is there's no opinions on the log format. So you can send us data in JSON, XML, CSV, unstructured. All formats are welcome in Loki, and then you can process them in many different ways. And number three, to make it very affordable. And what this results in is a much better workflow that you see here from the operator. So it's possible you get an alert in Slack. You might, log into your Grafana and you see your dashboard, and there it is right in front of you that there's a problem. You can go directly to your Prometheus data source, for example, and look at the metrics. Because of the correlation that we have between the metrics and logs, you can very quickly move in the same window over to your logs and correlate, hey, I have a metric, I have a log. And then you can even, if you're instrumented for tracing, for example, you can go into Tempo traces and look at your traces and back. So we have the three pillars of observability right there under this single pane of glass that you can get to very quickly. And now you don't have all that context switching that we did talk about before. So let's get into a little bit about how this works. So the first thing is, as I mentioned, Loki accepts it all. So you can send all your different logs from whatever systems you have, whether these are old monolithic applications, these can be bare metal servers, these can be Linux, Kubernetes, different platforms. You can send it directly and with the agent of your choice. So as an example, Dan had mentioned that at Roblox, they're using the Grafana agent. There are a handful of other agents supported, as you see here, Promptail, which is the one that we developed specifically for Loki. But if you're coming off another platform, you might be coming off of Elastic, for example, when you have log/RD in your environment, or Fluentd, FluentBit, or many others. You can just use the Apple plugins for those collectors and ship your logs up into Loki, which you can do either in Grafana Cloud, for example. We have a self-hosted platform, or a platform hosted by Grafana, or you can also self-host Grafana with Grafana Enterprise Logs, self-hosted. Now let's get into a little bit about the logging, what we call index-free logging, and it's not quite index-free, it's minimal index logging. So when you think of most other log aggregation platforms, they build those tools around the full text data. So what that means is that they are basically creating an index, and they're indexing the full log line, and it makes for a very, very large log line. Now, when you, I'm sorry, a very, very large index, and the index is about the same size as the actual data that you're ingesting. But if you think about logs in general, they're usually write once, read never. So why spend all that compute power creating these large index or indices for data that you're never going to read? And then throw more compute resources at the problem when you decide you need to read the data, right? So that's the big thing that we do, is we don't index everything. We just index metadata. And so basically what that comes down to for Loki, if you're familiar with Prometheus, they have labels. Loki, we do the same thing. You create labels, and then we create an index out of those labels, and it looks more like a table of contents. It's much smaller. And then from those labels, we can find the logs and do querying on that to find the data that you're looking for. So what that means for us is, for an index that's 200 megabytes in size, we have the ability to index, up to 10 terabytes of data. So very, very small. And a lot of these things you can do in RAM, for example, 200 megabyte index, maybe you have a Raspberry Pi, you can look to that index in RAM. So this isn't possible with larger log aggregation systems. And this here is just an example. If we look at the log line, this is just an example log line. We have a timestamp, we have some labels, and then we have the rest of the log line itself. So what we would index is a timestamp and a couple of labels, and not the rest of the log line. That will just remain unindexed. And we do a lot of querying. I'm sorry, when we want to actually get to the data we're looking for, we'll do that during the query portion. So just to add here, the trade-offs between the full indexing and the index-free, you can see on the left, this is what most log aggregation platforms do. Sometimes they may have a predefined log format they have to follow. The index is very large. So what that means is it's expensive compute power upfront to create it. It's also very expensive on the storage side to store it. Usually more expensive to run and complex to operate. It does have very fast queries, but again, if you're doing these write once, read never, or read rarely for your querying, maybe faster isn't always necessary. And then on the index-free, or the way we do things in Loki, we can log in all formats, very fast writes. The index is definitely smaller, cheaper to run, and very simple to operate. And we still have very fast queries. So diving in quickly to the architecture, this is a very high level architecture. The purple is the write path. So when we're ingesting data, So basically we have the agent here. I'm showing Promtail, but again, this can be the Grafana agent that we talked about earlier. That gets ingested through these distributors, which route the ingested traffic to these different ingesters. And there's caching at every layer in the stack. There's a lot of parallelism that happens here as well. And this is all based on object store. So very, very inexpensive storage, which is why that really brings the cost down for how much it costs to run your Loki log environment. And then on the read path, you can see that we have queryers. And the cool thing about this is this can come as a single binary, and you can deploy it as a single process, but it also comes as a microservices architecture. So as you want to scale out, you can scale out in parallel. You can do things differently on the read path and the write path, and scale out as you need it. So the question becomes, well, we do all this, but how do you actually get these fast queries when you have a small index? And that comes through a lot of parallelization. So we don't have that big reverse index, but in this example, you can see the query at the top. We're trying to find this particular trace ID, this number that starts with 611. We don't want to index data that has high cardinality. So you can imagine if you have things like trace IDs, IP addresses, things that are very high cardinality, that would help to balloon and create a very large index, which gets very expensive and not really good. So what we do is we split things in a couple of ways. First, we do it by time. So here you can see that on a 15-minute interval, we're splitting by time. And then we also use a sharding factor. And so basically what we're doing is we're taking those queries and taking those pieces and processing them in parallel. And more queryers means more parallelism, and that is what helps us result in faster queries. So once we run the queries, the results get aggregated back together and then presented back to the user. So what this results in is very fast queries, less storage, and you have the ability to decide how fast you want your queries to be by just adding more queries. So you have some trade-offs and some knobs to tweak between how parallel you want to be and how fast you want to be. So just a couple of examples of what this results in when you look in Grafana. One thing that I mentioned is how you can correlate your data between your metrics and your logs or your logs or traces. This is just an example where on the left side of the screen, I've visualized my metric data in Prometheus. And on the right, I'm correlating that data directly with the logs in Loki. So if you look at the screen here, what you can see is the query on the left for the under metrics browser for this particular web application. And you see the query on the right is pulling the same labels out. So we can do an easy, very quick correlation. This really happens automatically between the metrics and the logs. And so I can see very fast if there's an issue on the left, I can, if I go to the next slide, I can go on the right here. And you can see that I've scrolled down basically from that previous page, but I've scrolled down and found very quickly that there's an error on this page because of what's happening here. So there's a metric that's having a problem. I found that there's an issue in the log, and it's saying that there's an out of memory error. So very quickly under the single pane of glass in Grafana, I'm able to do this correlation between we have on the metric side and the log side. I'm not showing here in the screenshot, but what I mean in an actual screenshot here, but what you can see is we do have these buttons also that can link to Jaeger tempo. If you have tracing instrumented, you can also very quickly go from logs over to traces because we are pulling the trace ID out of this log. So again, metrics, logs, and traces, very fast through Grafana. And the last thing I wanted to show is this particular slide here. This is a very rich visualization made in Grafana. All of these panels are made from data that we pulled out of Loki. So they're all from logs. So we can pull metrics out of logs and create these nice visualization 100% from logs. So very powerful to do this, create good visualizations. You have the correlation and you have a nice inexpensive way to be able to have a nice log aggregation system that is also fast. So that's the end of my presentation. I want to stop here and pause and see if there are any questions.